Hey guys, welcome back. In this video, I'm going to teach you how to find a vector given 2 points and how to find a unit vector. First, let's give ourselves 2 points. The point P, 1, 2, which I'll call the initial point, and the point Q, 4, -1, which I'll call the terminal point. In order to find the vector, you have to do the terminal point minus the initial point. So what we're going to do here is we're going to say 4 minus 1 and -1 minus 2. Vectors are pretty much denoted by these bold letters, mainly V, U, and W. So we have 3, -3. We also want them to have these pointy ends to show that they're different from an actual point, P and Q. So that's how we find a vector. All you have to do is take the terminal point minus the initial point. Well, to find the unit vector, we're going to have to do something first. But before we do that, let's take a look at what this looks like on a graph. This is the point P and Q located at 1, 2, and 4, -1. This is what we call a direction vector. If you wanted to go and start from the origin, then what we're going to do is just take the vector that we created, which is 3, -3, and plot that from the origin. So we can plot it this way, and that will be a vector. We'll plot it this way, and that'll be a vector. This one is called direction. This one is called position. And regardless, vectors do not need to start at the origin, but a lot of times we make them start at the origin. A vector is defined by its magnitude and its direction. So let's figure out how to find the magnitude, which is also referred to as the length of a vector. It's actually really simple. If you take a look and you wanted to find this length right here, all you have to do is use a squared plus b squared equals c squared. The length from here to here is 3 units, and the length from here to here is 3 units. So what we're going to do for vector v, which is 3, -3, in order to find the magnitude denoted by these double lines, we're going to say 3 squared plus -3 squared square rooted, and that's going to be the square root of 18, which is also 3 square root of 2. So that's how we find the length of it. Why do we need the magnitude or the length? Well, in order to find a unit vector, we're going to have to divide each component by the magnitude. But first, let's try some practice problems here. The length of the vector, 3, 4, everyone should know what that length is. 5. We can figure that out by saying 3 squared plus 4 squared square rooted. The length of the vector 5, 12 is going to be 13. You can figure that out by saying 5 squared plus 12 squared square rooted. We're just taking the components, squaring them, adding them, and taking the square root. Here, I don't think you need to do much. What's the length? Just 1. That would make sense. If you plotted this, you would go 0, left and right, and then you would go up 1. The length of this is 1. Once again, if you go to plot this, you would go 3 over 4 up, and this is what we call our position. So now that I have these magnitudes, these lengths, how do I find a unit vector? Let's see. A unit vector is a vector that has a length of 1. In the beginning, I had 3, 4 as one of my vectors. I had the magnitude to be 5. All I have to do to find a unit vector is 3 over 5, 4 over 5. Remember that a unit vector has a length of 1. So let's see what this length is. A squared plus b squared equals c squared. This will be 9/25 plus 16/25, which will give you 25 25 over 25, which will give you 1. So that's how we find the unit vector. We just take the vector itself and we divide it by the magnitude. This can also be written as 3/5 I plus 4/5 J. If we are in the third, if we are in R3 or in 3D, right, 3 dimensionals, we will follow the same exact steps, but we'll just extend it. So let's try this one problem here. I have this point P and Q. We have X, Y, and now Z. Let's first find the vector PQ. Now we're going to do Q minus P because at the end, or the second letter is Q. So we're going to say 6 minus 2, 3 minus 2, 2 minus 1. Because this is the vector, I'm going to denote it with those sharp ends. In order to find the unit vector, I'm going to call this person V. In order to find the unit vector, I'm going to need to find the magnitude first. Well, instead of doing a squared plus b squared equals c squared, now you can just do a squared plus b squared plus c squared equals d squared. Whatever you wish. So that's going to be the square root of 18, which is 3 radical 2. Now we're just going to take each component, and we're going to say 4 over 3 radical 2, comma, 1 over 3 radical 2, and then 1 over 3 radical 2. That's how you find the unit vector. Come back for the next video.